Assalamualaikum and very good morning to Doctor and my friends. My name is Nuraina Maisara binti Nordin. With metric number 8 is 210028. So basically, I am from group 5. So today I'm going to explain the simulation of experiment 4, which is called as series RL and RC circuit by using multisim software. So now I'm going to explain about the activity 1, which is about steady state behavior of RL series circuit. So without further ado, we're gonna recreate the circuit for figure 4.5 by using multisim software. So for activity 1, the question 1 is to find the value of current, the value of power meter, and the value of voltage resistant, and also the value of voltage inductor. So to find all the value of the component, we decided to use the multimeter to find the value of current and also the voltage. Except for power meter, we're going to use the watt meter. As you guys can see here, the value of resistor that we're going to use is 33 ohms, while the value of inductor here is 50 milli. Besides that, the value of voltage source will be manipulated from 10 volts until 100 volts. But the value of frequency, we're going to state it with 50 hertz. Okay. So now we're going to try to manipulate the value of voltage to find the value of power factor, the value of current, the value of voltage for resistance, and also the voltage for inductor. So we're going to manipulate the value of voltage from 10 volts until 100 volts. So we try the first one, okay? So here is the value of current when we try to simulate the value of when it's come to 10 volt. So this one is the value of current. This one is the value of power factor. This one is the value of voltage of resistor, and this one is the value of the voltage for inductor. So next we're going to try to run for the next value. That's all the value that we get for when manipulate the value of voltage. So from that we can list down all the value for the voltage of resistor, voltage for inductor, power factor, and also the current. So that's all for the activity table 4.1. So next we're gonna move to activity 1, figure 4.6, which is recreate the RL series circuit by using multisim software. So basically in this circuit, the value of resistor that will be used is 300. So each resistor contain 100 ohm, while the value of inductor is 50 milli. As I mentioned before this, to measure the value of current and the voltage, we will be use the multimeter, while to measure the power meter, we're gonna be use the watt meter. So we're gonna repeat the same step as figure 4.6 to find the value of voltmeter, the value of current, and also the value of power meter. So that's all the measurement value for table 4.2. Thank you.
Hello, my name is Jackie Sandren and my matrix ID is 220168. Today I would like to do a simulation for lab for activity 2. So I'd like to start off the simulation by building the circuit which is shown here. So first and foremost, I've built the circuit partially, so I would like to start off and build it again. So this is the power source, AC power source. This is the watt meter. This is the multimeter here and here. So I'm going to connect all of the parts which are not connected. So first and foremost, I would like to connect the capacitor. Capacitor goes here, and then the capacitor goes here. Yeah, the capacitor goes here. Yep, and then this negative terminal of the multimeter is fixed accordingly and connected accordingly, and this positive terminal goes here and the negative terminal goes here. So that's about it. So now I'd like to start off the simulation to get the values. So these are is the completed circuit. So these are the values that I will be getting for my these are the values that I would be getting for my circuit. Yeah, so these are the values. Now moving on to the how do I proceed with the simulation is by by amending the voltage source. So in this it's 10, then it becomes 20, then it becomes 30, 40. So I can do that as well. So what do I do is I stop the simulation. Because I will amend this to 20. So I've changed the voltage source 20. Now let's run the simulation. Now I get the values. So these are the values that I have gathered and inserted over here. So 132 milliampere, it's returned here, 132 milliampere, and then 13.23 volts, 14.96 and 1.75 watts. So 1.75 watts here, and the 14.996 is the XMM30 is here, the parallel voltage of the capacitor, and also the parallel connected multimeter to the voltage source is 20. So that's all from me. Thank you.
Assalamualaikum and a very good morning. My name is Jafta binti Rosli and my metric number is DE21003. Today I'm going to explain to you guys about activity number 3, where there are two questions. For question number 1 is we have to plot the graph of VR versus I and VL versus I and P versus I. So the first thing I need to do is the graph for VR versus I. There are two graphs that I need to do, which is for table 4.1 and table 4.2. We from this graph we can observe that table 4.1 that as the voltage supply increase, the current passing through also increase. The value of current when 10 volt supply voltage is applied is this 2.073. We got the value of VR is 9.024, but the difference for table 4.2 is the value of current is 0.271 and the VR is 9.041. So from this graph we can see that the value of table in 4.1 is more than the table 4.2. Next one is graph VL versus I, and this is the graph for table 4.1 and this one is for graph table 4.2. And as you can see from this graph, we can see that the VL in table 4.1 is more than the table in 4.2. And as you can see that when the current is 2.734, we get the value of VL is 43.092. Meanwhile, in current 2.741, we get the VL of 42.74. So we can see that the value is much higher in table 4.1. Next one is power versus VI curve, and this is the result for table 4.1 and this is the result for table 4.2. So as you can see the result, the power in table 4.1 is much higher than the table in 4.2, which is the table, the highest value is 246.759. Meanwhile in table 4.2 we get the value of 245.198 watt. So next question is draw to scale the phasor diagram for the circuit based on the voltage reading obtained when current is 1 ampere. So the first thing we need to do is to find the XL, which is the formula is 2 pi FL. So we get the value of 15.708 and same as the in table 4.2. The difference is that when we want to find the impedance, which is for table 4.1, the value of impedance is 36.548, meanwhile for the table 4.2, we got the impedance of 101.226 ohm. So from this equation, we get the voltage for 4.1 is 36.548 voltage, meanwhile for 4.2 is 101.226 voltage. So the angle that we got for table 4.1 is 25.454, meanwhile for table 4.2 we got the angle of 8.927. So this is the phasor diagram for table 4.1 and this is the phasor diagram for table 4.2. So for question number 2, we have to plot graph of VR versus I, VC versus I, and P versus I. So the difference for question number 2 is that we need to do for the capacitor part, meanwhile for activity number 1, we need to do for inductor part. And then this is the graph for 4.3, and as you can see, this is the graph for VR versus I for table 4.3, and this is the graph for VR versus I, table for 4.4. And as you can see, this is the graph of linear relationship because it's in a straight line. And as you can see, the value of VR is much higher in table 4.3 than table 4.4 because when the current is 0.807, we got the VR which is 66.167, and for table 4.4, when the current is 0.807, we get the VR is 40.369. So that's the graph for VR versus I. And the next one is graph of VC versus I, and this is the table for 4.3, and this one is for table 4.4. And as you can see, value of VC in table 4.4 is much higher than the table in 4.3 because the maximum VC is 91.489 for table 4.4, and while in table 4.3 we only got 74.978 voltage for table 4.3. The next one is power versus VI, which is, as you can see from the graph, it is a linear relationship graph because it is in a straight line. And as you can see, the maximum value of power for table 4.3 is 43.782. Meanwhile, for table 4.4, the value is 32.593 watt. And from this graph, we can identify that the shape of the graph VR versus I, VL versus I, and power versus VI represent a linear relationship graph. The reason I'm saying that is because a linear relationship between two variables that produce a straight line when graph. So from the graph, we can see that the value of x-axis increase when the value of y-axis also increase. Last question is draw to scale the phasor diagram for the circuit based on the voltage reading obtained when I is 1 ampere. The first thing we need to do is to find the XC, and the value that we got is 113.682, which is same as the table 4.4. And then the next one is we need to find the value of impedance, and for table 4.3 we got the value of 151.405, meanwhile for table 4.4 we got the value of impedance is 124.192. So to find the voltage, we can take the value of impedance and times with current. So we got the voltage for table 4.3, which is 151.405 volt. Meanwhile for table 4.4, we got the value of voltage is 124.192. So the angle for table 4.3 is 48.664. Meanwhile for table 4.4, we get the angle of 66.259. So as you can see, this is the phasor diagram for table 4.3. Meanwhile, this is the phasor diagram for table 4.4.